Alright, so in this video we go over section 2.2 Introduction to Problem Solving, in which we are going to learn how to write an algebraic expression that can be simplified from a real life situation, from a few examples that we're going to do, and then we are going to use that information to solve problems using what we're going to do first, and then solving equations, solve problems. Alright, so a very classical problem here is they ask us to write the perimeter of a triangle with sides, with the given sides that are x, 5x, and 6x minus 3. So in this case, they're not in as usual, they're not given in just numbers and we add the numbers. So in this case, well, we're gonna have the triangle right here and the length of their sides in terms of algebraic expressions. So first of all, before finding any perimeter or anything, okay, let's write down the formula to find the perimeter of a triangle. So in this case, well, a triangle has three sides. We can label the sides as A, B, and C. And in this case, regardless of the order, for example, this 5x could be our A, this 6x minus 3 could be the B, and this x could be the C. Alright, so the perimeter P then will be whatever A is, which in this case is 5x, plus whatever B is, which is 6x minus 3, and plus C, which is simply x. Okay, so all we do now is to combine like terms. So 5x plus 6x is going to give me 11x plus another x. So let's highlight them just so we know which ones we are combining with. So that's going to give me a total of 12x. And then this negative 3 is just going to be there. So in this case, they are not asking us to solve anything. They just ask to find the perimeter of this triangle in terms of the variable x. All right. Very similar situation in example 2. Okay, so we have this a very typical enclosing area problem that is near a river. So typically what they do is fencing around except along the river. All right. So in this case, well, this is being fenced in a way that we form 1, 2, 3, and 4 rectangles. And in this case, well, we have some information a little bit hidden, if you will, but it's not quite hidden. We're going to break this up in a moment. All right. So these lengths in question mark, they are exactly the same as this one right here. So this is this length right there, 3x minus 15, which is the same as that one, and also the same as that one, and also the same as that one, and finally the same as that one right there. Okay. All right. So if you want to write this as a note, these lengths are 5 times the quantity 3x minus 15. Okay, so, and then over here, what do we have? Look at this look at the total length right here. So in this case, the length of each individual rectangle is x, but in this case we are going to add them all up to get 1, 2, 3, 4x. Okay, so we get 4x. So they're asking us to express the total amount of fencing as an algebraic expression of x, just the same way as in the previous example. So the perimeter, well, if you will, the perimeter, or I'm going to call it simply total amount of fencing. So in this case, it's going to be the total length okay, which is that quantity there, plus 5 times the width. All right, 5 times the width, which in this case will correspond to this quantity. Why 5 times? Because we have again 1, 2, 3, 4, 5. Yes, we have 4 rectangles, but we have a total of 5 fencings in this case. So this will be the total length, which is 4x plus 5 times the quantity 3x minus 15. So in this case 4x plus, what did we do in the previous section in this case? Remember, distribute. Okay, so distribute 5 times 3x, that's going to give me 15x, and 5 times negative 15, that's going to give me negative 75. And then we combine these together to obtain 4 plus 15, that's a 19. 19x minus 75. Okay, final answer in this case. Okay, again, they're not, I'm going to use big T for total. We are not asked to solve for anything. That's what we're going to do in the next part of the section. So let's see. Let's move to the next page. So, oh, we have another one, I think. Okay, this one is a very interesting one. So we have a section of some architecture plan right here, and they're asking us to find the total perimeter as an algebraic expression in X. So it would be a good idea to label all the sides, because we have quite a good number of sides in here. All right. So let's see. I'm gonna label the 8. I'm gonna start with the 18. I'm gonna call this A. And then this x plus 14, I'm gonna call this B. And then this little side right here is gonna be C. And then this tiny side is gonna be D. This 10 will be our E. And this F equals to x plus 8. Alright, so let's see how are we going to write down. Well, we're finding the perimeter, so all we do is add them all up. However, we don't know what C is, and we don't know what D is. We are going to figure out what C is. So, C. We can get this quantity C by subtracting the E from A, that is A minus E, which is 18 minus 10, which in this case is 8. See what I'm doing? Well, so we know the total height, which is 18, and we already know some part of the height, which is 10. The remaining by difference, that's going to give us C. What about D? Well, letter D is going to be a little bit tricky, because that D itself is going to involve x's as well. So how do we do that? Well, we know the length of the base, which is B, and we can subtract this part right here, which is F. That's going to leave us with the quantity D. So B, which is x plus 14 minus the quantity x plus 8. And that's going to give us, well, x plus 14 minus x minus 8. And that's going to give us x. Notice how the x's go away. They cancel. And 14 minus 8 is 6. So c equals to 8 and d equals to 6. Alright? So now perimeter, which will be P. Big P will be the sum of all the sides, A plus B plus C plus D plus E plus F. Okay, so the three sides. Okay, what is A? That's 18 plus B, which is x plus 14, plus C, which is 8, plus D, which is 6, plus E, which is 10, plus F, which is x plus 8. And all we do is just add those quantities together. Well, how do we add them? Again, keep in mind that we combine x's with x's and numbers with numbers. So what I like doing when combining like terms, I put a bar below all the x's, put a bar below the x's, and just a wiggle below each number. So in this case, well, let's add up all the numbers. Well, we add the x's first, so we have only two x's. P equals to 2x, and all the pure numbers, so that's 18 plus 14, that's 32, plus 8, that's 40, plus 6, that's 46, plus 10, that's 56, plus 8, that's 64. And that's about it as far as this problem. Again, we are not asked to solve anything, just to express this perimeter in terms of an algebraic expression. Alright, applying the steps for problem solving. Well, every time we have a word problem, the first thing we do is to understand the problem, and that may require to do a drawing, a sketch, or something to help us understand the problem. That way we can label the quantities that we have, the ones that we don't have, and the ones that we are being asked to find. Alright, and then from there, well, the second step is translate. Well, in the same step, rather, we choose a variable to represent the unknown quantity. Well, typically we use the variable x, right? So I guess there's no way to go wrong for that part. Then translate the problem into an equation. Well, how do we do that? Well, that's going to depend on on the situation. Maybe it's a perimeter problem. Well, we add the sides, and we are going to add all terms of x. Or maybe it's an area problem, then we multiply some quantity. Well, it's going to depend. So we solve the equation the ways we have done it before. We find the result, but we are not just looking for the result of the equation. We are using the solution to that equation to actually answer the question for the problem. All right, so let's look at one example. I think that's going to be a really good visual to, to actually be able to interpret this. All right, so find three numbers such that the second number is 3 more than twice the first number, and the third number is 4 times the first number. Well, what's interesting here? First of all, notice how everything is about the first number. So everything gets referenced towards the first number. So that's going to be, okay, yeah, I already said it. That's going to be our reference. That's what we're going to give some letter, some kind of variable, But also this is what we are going to do. If possible, okay, let's highlight all pieces of information. I'm going to highlight with one color the first piece of information. So some second number, the second number is 3 more than twice the first number. Do we agree with that? Well, that's one first piece of information. The second piece of information is going to come from the next sentence. The third number is 4 times the first number. All right? So those are the two pieces of information. All right. So as a note, you might want to notice in this case, notice how everything it's all about, everything is about the first number. Call it X. Call that X. That's going to be our X. All right. For example, if you have a similar problem that said, well, twice the second number and another number is twice the second number, well, everything would be about the second number. Well, how are we going to label them and how are we going to do the setup? So we have a first number. We have a second number. We have a third number. Since everything is about the first number, that's the one that we are going to call X. Now, using the information from the sentence I highlighted in green, the second number is 3 more than twice the first number. 3 more, that is something plus 3. 3 more than twice the first number, that is 2x. In other words, 2x plus 3 is the same as saying 2 more than twice the first number. And I'm going to highlight this with in green just so you can see the connection. Where is this 2x plus 3 coming from? Comes from that piece of information. And I'm going to do the same in the next case. The third number is 4 times the first number, simply 4x. And I'm going to use right, 4x. I'm using the same color so you can see, so you can see the connection. Where is that coming from? All right, what is the extra piece of information? Well, now let's read the last sentence of the problem. The last sentence of the problem is telling us that the sum of the 3 numbers is 64. Okay, so that's going to give us an equation. This, I'm highlighting it with yellow. We can barely see it, maybe. Hopefully it looks yellow. Yeah, yes, it does. All right, alrighty. Let's see. So that means from here, from that last piece of information, we have that first plus second and plus third equals 164. Okay, so I'm going to substitute this guy right here, first, second, and third. From there, I'm going to write an equation that I'm going to solve in a minute. So x plus the second, which is 2x plus 3, plus the third, which is 4x, equals 164. And from here, well, it's all about combining like terms as we did in the previous section. So combine the x's, x plus 2x, that's a 3x, plus 4x, that's a 7x. and then plus these 3 that we have here. Alright, so now let's solve this equation. Well, subtract 3 from both sides to get 7x equals 161, and then divide both sides by 7. And you might want to verify this using a calculator, and that's going to go evenly. X equals to 23. Alright, so this is only the solution to the equation. We are not done with the problem. We're not we're not done with the problem. We need to go back and answer the question. What are the 3 numbers? Find 3 numbers. Well, so the first number is simply x, in this case 23. Okay, that's done. Second number is 2 times x, which in this case 23, plus 3, which in this case that equals to 49. That's the second number. And the third one, that's simple, that's 4 times x, but x again is 23. And that's going to give us a 92. Now, if you add these 3 numbers together, you should get 164. Let's go ahead and do that. Let me get my calculator here real quick, just so I can show you. All right. So here, 23 plus 49 plus 92. That equals 164 indeed. All right, so let's go ahead and move on to the next example. So what are they telling us in this case? Well, it's at the top of the page. So one aircraft has a capacity of 91 more seats than the second aircraft. A third aircraft has 95 seats, less than twice the seating capacity of the second aircraft. If their total number of seats is 1,876, find the number of seats of each aircraft. All right, so what do we have first of all? So we have a first aircraft, we have a second aircraft, and we have a third aircraft. All right, let's highlight the pieces of information again. So let's see. One aircraft has a capacity of 91 seats, then a second aircraft. And then a third aircraft has 95 seats, less than twice the seating capacity of the second aircraft. All right, notice how everything is about the second aircraft, So in this case, that's going to be our x. Remember how in the previous problem, everything was about the first number? Well, that was x. In this case, everything is about the second aircraft. So 91 more than the second aircraft. So that is something plus 91. That is x. And the third aircraft has 95 less than twice the second. That is 2x. All right. So in this case, well, the very last piece of information is telling us that if their total amount of seats, if we combine all the seats together of the 3 aircraft, well, then we are going to have a total of 1,876. All right, so let's see. First plus second plus third equals 1876. That is, we are going to write for the first one, that's x plus 91, x, and 2x minus 95. That is x plus 91 plus x plus 2x minus 95 equals 1876. Alright, so combining the x's together, we are going to have a total of x plus x, that's 2x, plus 2x, that's 4x. And 91 minus 95, that's negative 4, equals 1876. So now let's solve the equation by adding 4 to both sides. And that's going to give us 4x equals 1880. And divide both sides by 4 to get x equals 470. So that's only the value of x. That's not the final answer to this. So we need to go back to this quantities here. So first aircraft is x plus 91. That is 470 plus 91, and that's a total of 561. Second aircraft is simply x, in this case, well, 470. And the third aircraft is 2 times 470 minus 95. And if you use a calculator, you should get 845. Okay, let me do it again in the calculator just to verify that we are correct. So 2 times 470, and then minus 95. And that's indeed correct. So that's final answer again. X is not the answer. The answer is this. The answer to each of the number of seats for each aircraft. All right. Another very typical problem that involves solving an equation is the one that involves percentages. All right. So we have the situation here that a university president's salary for the 2012-2013 academic year was $491,000. Calculate his 2013 to 2014 salary if he received a 2.6% raise. Well, how are we going to do that? Before crunching numbers or such, first of all, we are going to write this equation in words. Okay, so what do we have? That the new salary equals the old salary plus raise. All right? That's what we would think every time we have some situation like this. So the new salary, which I'm just gonna call it big N. All right? Call it big N. Doesn't matter. And then the old salary, or you could call it X if you want. Well, I'm just using the big N just to relate it to the context of the ongoing situation here. All right, so then what are we going to have now? So let's see. Old salary, which we have here, which is 491,000 plus the raise. Okay, but how do we define the raise? The raise will be the old salary times whatever the raise is, which is 2.6%. But remember, we don't write percentages in equation, we need to change this to decimal. So this will be 0.026. All right. 491 0 plus 0.026 times, well, I'm going to put the multiplication, the point instead of actually, never mind. It looks kind of ugly this way. I'm just going to put parentheses. I'm going to move the parentheses, 491,000. So first we multiply these two numbers. What do we get when we do that? Well, let's see. 0.026 times 491 times 491,000, and that's 12,766. All right, and then from here all we do is combine these two numbers together. So that number plus 491,000. Okay, so that's going to be the new salary. Of course, because he got a raise, we would expect a larger number, of course. And you might want to include the dollar sign. And that's final answer for this problem. All right, let's see. What's next. What do we have? All right. So we have another percentage problem. Well, a networking company recently announced it would be cutting 6,800 jobs. This is the equivalent to 7% of the company's workforce. Find the size of the total workforce prior to this round of layoffs. Well, all right, so that is, in this case, this means that they are going to cut a total of, let's see, something is going on here. Let me, yeah. Okay, so 6,800 or 6,800 represents the 7% of what number? So let's write that one in words first. So 68,000 is 7% of what number? That's the question we're being asked. All right, let's turn this into an equation. So 68, keep in mind that the word is means equal sign. All right, is means equal sign. 7%, well, turn that into a decimal. 0.07 of means multiplication, and then what number? Well, that's a question mark, right? That's our question mark. The what number in this case is x. All right, so we are being asked to solve this very simple equation. All right, so let's see. We need to divide both sides by 0.07 to get x by itself. So x equals whatever we get from dividing these two numbers together. All right, let's do it in the calculator. 6800 divided by 0.07, and we get that big number. And in this case, notice how I get decimal, so I'm going to round up to the next integer. That is 97,143. Alright, so interpreting the solution to the problem, well, it means that the company has a total amount of 97,143 people working for them. Counting 6,800 jobs means the 7% of that big number. Alright, so let's see. Let's do one more example. Let's look at one more example and call it a night for this. Alright, so let's see. Example 5. Find the measures of the angles of a triangle if the measure of one angle is 3 times the measure of a second angle, and the third angle measures 4 times the second angle. Notice here, everything is about the second angle. Second angle. Did you see that? Right? Okay, let's highlight the pieces of information. Let's highlight this one angle is 3 times the measure of a second angle. And then the third angle measure 4 times the second angle decreased by 60. Alright, so let's see. Let's set it up the same way we set up the other few problems. Alright, so that's first, well, second, third. Okay, so since everything is about the second angle, that's our reference, that's going to be our x. One angle, that means by one angle they mean the first. Alright, how do we know that? Well, because over here they're calling for some second angle and a third angle, so this has to be strictly the first angle, so that has to be 3x. And the third angle is 4 times the second angle decreased by 60. Okay, 4 times, that is 4 times x. Decrease means subtract. That is minus 60. Alright, so apparently here we have all the information, but not quite, because, well, we're talking about the angles inside of a triangle. Apparently we have some missing information. So first plus second plus third. But what is that going to be equal to? They're not telling us anything. Well, in this case, one thing to keep in mind is from basic geometry, the sum of the inner angles of a triangle is 180 degrees. All right, that's a fact from geometry that you need to keep in mind, All right, that's something we need to know, in any effort to solve this problem. So we need to set this equal to 180. So now let's write down this in terms of our variables x. 3x plus x plus 4x minus 60 equals 180. And as usual, combine the x's together. That's a total of 3x plus x. That's 4x plus 4x. That's 8x minus 60 equals 180. Now solving this equation for x, add 60 to both sides. and we get 8x equals 240, and then divide both sides by 8. That's going to be x equals to 30 degrees. If you want to use the degree symbol, that's fine. Okay, so in this case, this is not yet the final answer. We need to go back and check in with this setup that we have. So how do we do that again? The same way. Okay, so first angle, 3 times x, which is 3 times 30. And that's 90 degrees. Second angle, that's simply x, which is 30 degrees. And we're done here. And finally, for the third angle, that's 4x minus 60. That is 4, the value of x, which is 30, minus 60. And that's 4 times 30, that's 120, minus 60, and that is 60 degrees. All right, and I believe there's no more else to cover for this section. So yeah, this is a good place to quit. I'll see you on the next video.